Hey guys, what's up? Welcome back to AlgoYogi. We are doing binary search series and our next problem is search in a 2D matrix. Let's go to LeetCode. So you are given a m into n integer matrix called matrix, so unique, with the following properties. Each row is sorted in non-decreasing order, basically increasing order, but not strictly increasing order. The first integer of each row is greater than the last integer of the previous row. So this first row is 1357, so, and the next row starts with 10, so see 10 is greater than 7. And so given an integer target, return true if target is in the matrix or false otherwise. Such a simple problem, right? You have this m into n size matrix, so why don't you do a linear search, two nested for loops, one iterating all the rows, another iterating basically all the elements in each row. That will give you a big the time complexity of m into n. We don't want that. That's easy to do. You can write it yourself. That could be your brute force solution. But we need to write a solution that is log m into n, which is binary search. We're gonna apply binary search here, guys. Yeah, let's go. And what am I doing? Okay, so let's switch our view. Okay, so how are we gonna do it? First thing first, we're gonna find the row where our target should be. So first example, you can see our target is 3. Our first job, so our matrix is basically m into n size. So we can say just, this is m and this is n. That's the size of our matrix. First thing first is we want to find out which row my target would be in. So I will apply a binary search vertically, right? I will apply a binary search vertically, so this way. So I will have like a left row and then right row, and then I will start searching by finding out the mid. I'll find out the mid. In this case, it would be the mid would be just the first row. Like if it is 0, 1, and 2, only 3 rows. So 2 divided by 2 is basically 1. So first row. Actually, that's not going to be first row. 2 divided by 2 will be our first index. Actually, it's just exactly middle row. So my bad over there. So this will be my first mid row that I find out, and then I'll see, is my target between 10 and 20 inclusive, right? If it is not, then I'll check if it is it lesser than 10 or is it greater than 10, and based on that I will basically shift my left row pointer and right row pointer. And once I basically find out which row my target is in, then I will basically, so in this case you'll see that target 3 is not in between 10 and 20, it's basically less than 10. Then I will move my this pointer. So basically I'll move my, let me just clean it up. So I will move my right pointer, so basically just mid -1, which would be 0, and my right pointer still points to the first row. Now if I take out the mid here, then it will be 0 itself, and we know that my target exists somewhere in this row. So this row, I have located the right row now, and then I'll apply another binary search with left and right pointers here, and just finding out the target. That will become a normal regular binary search operation, and you know that. Then our time complexity would be big of m into n. So this m is basically you're finding the right row first, and this is the direction you are basically trying to search, so that's where the m comes from. And then this n basically is where you are searching, applying the binary search horizontally to find the right element. And once we find out the right row, we'll just have like another while loop inside that, checking for the in a binary search algorithm, right? Find the target. If you find it, that's okay. If you don't find it, return false inside, because now you are in the right row. If it doesn't exist in the right row, it wouldn't exist anywhere in the matrix, because every row is sorted, and basically the entire I was gonna say that the entire all the elements are kind of sorted. If you go in this zigzag motion here, so basically this is what I'm talking about. So this way, so they're all sorted in this way. If number doesn't exist in the right row, or like maybe in this case 13 was supposed to be basically in this row, and if it's not here, then it's not going to be anywhere else. It's not going to be in this row or this row. So once you find out the right row and it doesn't exist there, then just you can return false there. Okay, so we're going to write out the solution. It's going to be really easy. So let's switch the view here, and awesome, looks good. So let's have left row and right row RR. This is basically to find the these two pointers are pointing to the first row and last row, since we are trying to find out the right row in which my target will be located. So it will start with 0, and then it's going to have length of the matrix, so I'm just gonna decrement it by 1 because index starts at 0. So let's start our while loop until LR is smaller than or equal to RR. Then we're gonna find out the mid. Let's find out the mid. So mid would be basically LR plus RR. You can do the overflow thing, but I guess it's not been overflowing recently. What I mean is, like, overflowing is like when you basically have LR plus RR minus LR by 2. So basically you are adding to your left pointer the difference of the half of the difference of both these pointers. That will get to you to the mid as well without overflowing, the added value. So, but this is all okay. Now let's check if basically my target is in this mid row that I just found. So if my target is basically greater than or equals to my first element of mid, my first element would be 0. If this is true, and my target is smaller than or equals to, if this target is smaller than or equals to basically the last element, and the last element would be just -1. All right, so if this is true, that means my target basically exists in this particular row. So what I can do is I can again start my left and right pointers on this. So this is like my second binary search. First one was to basically find out the right row, and also let's before we do that, let's write down its elif case, where if target is basically greater than, or let's say target is smaller than the first element of this row, the mid row. If this is target is smaller than, then I need to bring my right pointer to basically mid -1. All right, else the last remaining case is target is greater than the last element in this particular row. Basically it's going to be -1 over here, but we're not writing it because it's else case. It's like, what else is other thing going to be. So it's just our target is going to be greater than the all the elements in this row. So we're going to take our left row pointer to mid plus 1, right? And if we come out of here, we can just return false. But because we found out the right row, so we're gonna basically also return from here as well. So this is going to be 0 and length of basically mid, or you can even say this 0 as well, okay, or any row. I mean, I'm just gonna say mid, but all the rows will have, you know, since it's a matrix, it's gonna be, I could put 0 here, 1 here, or whatsoever. It's taking out the length of all the rows will be same. And small minor mistakes, we want to have the right index. So let's start our while loop. While left is smaller than or equals to what? My right pointer. Find out the mid. Let's this time represent, because mid is already taken, so let's represent it by m. So left plus right divided by 2, and now we're gonna check. If is there some indentation problem here? I think there is. We don't want that, right? Yes. Okay, now beautiful. So if basically the number matrix, basically mid is what I am right now searching. So mid, and which element? M. Okay, so mid row and m element inside that row, m index. If this is equals to my target, then I will just return true, right? I will just return true. Else if basically this element is greater than my target. If this is greater than my target, that means what? My target will be located in the basically first half, right? Because the mid that I just found is greater than my target, so my target is going to be the first left half. So to get left half, bringing down our input size to left half would be done by, if I move my right pointer from the right end to mid minus 1, so that left remains over there, right comes to basically pointing mid minus 1, m minus 1, and input side becomes half, basically what it was before. Else, last case would be basically moving my left pointer. That means my target must have been greater than my mid element that I just found, so I will move my left pointer to mid plus 1, right? Final thing, we come out of the loop, and since we are searching in the right row, we did not find out the number. So what we're gonna do, we don't want to create this infinite loop, because otherwise what will keep happening is we keep coming here and keep doing again and again the same search, but the number is not present. So we don't want to like create that infinite loop. So while we come out of this loop and we found out that if the number existed, we would have returned it from here, but since it didn't, that means it doesn't exist anywhere in the list, in the matrix. So we just return false, right? And that would be it. Okay, so I'm just gonna, so that the entire code is like correctly visible, I will zoom out, just give me 1 second. Okay, so just this thing I'll like separate out, a little over here, a little over here, and then over here. Okay, awesome, code looks perfect now. So I'll zoom out and let's test this little baby. This is our little baby, right? Okay, I hope there's no mistake. Okay, just a little unindented. That is little unindented. Awesome. हुस्न का दरिया है मैं प्यास पुरानी. Okay, let's submit our answer. Bye bye, 100%. Okay, let's write the time complexity, guys. Time complexity, very important time complexity. What is it? Big of log m to find the right row, and into, because for we are doing it basically first you find the row and then you find the they're nested, they're nested, these two loops are nested, and n, log m into n, right? Okay, let's go back to AlgoYogi and mark this. So I still haven't fixed that problem where I have to double click it to mark it. So bye bye guys, I'll see you guys later.